is to use linear attract to investigate Newton's second law of motion. Newton's equation of motion for a point of mass m to which a force F is applied is given by the following: F equals to ma, and we can see how it was applied in figure 4.1.
Refers to the movement of an object along a straight line path. It can be described by the object's position, velocity, and acceleration in relation to a fixed reference point. Linear motion is opposed to rotary motion, which describes the movement of an object around a central point. Linear motion can be caused by a variety of factors, such as forces acting on the object or changes in potential energy. Understanding linear motion is important in fields such as physics, engineering, and mechanics.
For this experiment, we need some apparatus, which are air track rail, blower, pressure tube, gliders, string, flag, photo gates, messes, mess hanger, and pulley.
1. Assemble the linear A-track set as shown in figure 4.2. 2. Switch on the pump and let the A blow through the track for several minutes. Balance the track by adjusting the screw on the leg of the track so that the glider stay stationary and does not glide to either end when let go. 3. Insert one hook at one end and a flag on the top of the glider. 4. Measure and record the mess hanger and the length of the flag. 5. Attach one end of the string to the hanger and to another end to the glider. 6. Place messes with a mass 20 gram on the hanger and put the string over the pulley. 7. Position the glider exactly before the photo gate. Release the glider and record the time shown on the photo gate. 8. Repeat the experiment 2 more times to obtain the time average values. 9. Repeat the procedure 4 more times with 2 gram each added to the hanger.
Proceed to the result of this experiment. The length of flag in this experiment is 0.10 meter and the mass of hanger is 0.0099 kilogram. Firstly, we need to calculate the total mass of hanger and slotted masses by adding the mass of hanger with the total of masses on hanger. After that, we calculate the weight of hanger and slotted masses by multiply the mass of hanger with the value of gravity, which is 9.18. Lastly, we find the acceleration by multiply the length of flag with 2 and then divided it with square of time taken.
Here is the analysis of our experiment. So at the first one, as you can see, we include a graph in the slide. That is the graph of weight force versus acceleration we plot. Number 2, based on our analysis, the graph tells us if the weight of hanger and slot masses increase, then the acceleration will increase too. Number 3, do these results support Newton's second law? So firstly, Newton's second law states that the acceleration is depend on two variables, which is the net force acting on the body and the mass of the body. The acceleration of the body is directly proportional to the net force acting on the body and inversely proportional to the mass of the body. This means that as the force acting up an object is increased, the acceleration of the object also will increase. Likewise, as the mass increase, the acceleration will decrease. So we can conclude that the results support Newton's second law.
From the experiment, we can conclude that linear air track was used to investigate Newton's second law of motion and obtain the required data for the experiment. Furthermore, the apparatus such as air track rail, blower, pressure tube, gliders, flag, photo gates, messes, mess hanger, string and pulley was used to achieve the objectives of this experiment. Based on the law, it is also stated that the higher the mass, the more time that will be taken. From the experiment conducted, the law was used proof. In addition, we can conclude that the acceleration also increased linearly with the mass by the end of this experiment.
There's a few applications of linear motion in our daily life. The first one is sliding door. It moves in a straight line when it is pushed or pulled along the casing. This will let the person open or close the door as needed. Second, motion of bullet fired from gun. A bullet will travel in a straight line until it reaches its target when it's fired from a gun. It does not alter its course. The third one is opening and closing a desk drawer. The drawer can only move in a straight line when open and closed. Last one is elevators. Elevators were used widely, especially at the spacious place to facilitate our movement. These elevators move in a straight line in an up and down motion. As a result, it is considered to have rectilinear motion.